Hey there, how's it going? Can I show you something? Check this out. Hello! Well, what do you think? It looks cool, right? Wait, hold on, I forgot something, I'll be right back. There we go, that's much better. What you're seeing here is a motion capture system that I built, and I'm sure you're wondering how I did it. Well, keep watching and you'll see exactly how I made this possible. All the problems I ran into and how I solved them is quite entertaining to watch. So, are you ready? Before I start, I have to tell you something. I didn't really plan for this video while I was making the software, so the rest of this video is just me trying to remember what happened in the past 2 months. Hopefully, it all makes sense. The biggest question on your mind right now would be, why am I even making this? Well, it looks really cool. I mean, what other reason would I need to build something? And I get that it's not a satisfying answer, so think about it like this. The world of motion capture is like a spectrum. On one side, you have all the high-end tech. I'm talking suits, cameras, and other equipment that can cost anywhere from thousands to tens of thousands of dollars. Clearly, something only people with money can afford, like film and game studios. If you've ever wondered how your favorite video game or movie characters are animated, this is what they use. On the other end, you have an emerging industry of virtual YouTubers, VTubers for short. They mostly rely on face tracking apps to simulate motion for their 2D models. Although, some VTubers do use 3D models with the same face tracking tools. And then, you have the occasional YouTuber who is able to afford the expensive gear. Or maybe they just use VR headsets, I'm not really sure. Now my goal is to fit somewhere on this line where I can make something that doesn't cost me an arm and a leg, but also feels like real motion. So, where do you even begin? Well, I don't think it would be very practical to make my own motion capture suit, so I went with the next best alternative, machine learning. Now, before someone goes down in the comments and says I'm using AI to animate the character, I'm not. This is not a large language model, and I'm not using natural language to generate anything. What these models really do is take images and tell you where all the joints are. It's pretty cool. Oh, and this works with regular webcams like the one I'm using. You don't need any special motion capture camera. You know, this was surprisingly easy to code. I have a feeling this project will be quite easy to finish. And if we take a look at the output, well, what do you know? It looks amazing. For those of you who are actually watching and not just have this playing in the background, you might have noticed a few issues. For starters, the frame rate is amazing. I think I'm almost getting 3 frames a second. PowerPoint would be jealous right now. And secondly, you see these points all over my body? Well, those points are all in 2D. And for someone who lives in a 3-dimensional world, I'd prefer if the virtual representation of myself was also in 3D. And I'm not kidding when I say this, but the rest of this video is just me trying to solve this one specific issue. As for the frame rate, I don't really care. This will all be post-processing anyway, so it's not an issue. So how do you turn 2D coordinates into 3D? I have 2 words for you, depth perception. And to understand what I mean, we need to talk a little bit about biology. You see, most people have 2 eyes, and each one sees the world slightly differently. You never realize this because your brain does a really good job at putting the images together into a single output. If you want to see this for yourself, try this. Take a couple of objects and place them at different distances from yourself. Close one of your eyes, look at the objects, and then swap which eye you're looking with, and you'll see a visible difference. Alright, class is over, let's get back to the video. So by taking inspiration from the real world, I'm now using 2 cameras to perform a mathematical operation called triangulation, where you take 2 known points to find the 3rd unknown point. This is the same thing Minecraft speedrunners use to find the stronghold. After a lot of coding and setting everything up you need for triangulation, I recorded my hand to see if all the effort I put in would finally pay off. I took both recordings, ran them through the code, which finally gave me 3D coordinates and rendered out the result. And for the first time, I had tangible results for my efforts. And honestly, it didn't even look that bad. As long as you don't look at it from this specific angle, it's pretty normal. With that boosting my confidence, I went ahead and recorded my full body and went through the process again. And it was completely awful. I don't understand what went wrong here. It doesn't look like triangulation worked at all. And after coming so far and having put so many hours into this solution, I gave up. And there's a very good reason why. Allow me to show you the exact process it takes to take one recording and turn it into a 3D animation. First, I need to place the cameras at a specific distance from each other. I need to stand at a certain distance from the cameras, record the footage on both cameras, go into a video editing software to make sure the videos are lined up and trimmed, run the videos through 2 different programs that I wrote, export the data, import the data into Blender, run more code to build the animation, and finally render it. I might have forgotten something here, but you get the idea. The process is long, convoluted, and if anything goes wrong at any point in the process, this whole thing falls apart. Which is probably what happened here. That's too many volatile variables to deal with. So I did the most logical thing and deleted almost everything and went back to square one, where I had a single camera and 2D data from the machine learning model. By this point, I was completely worn out. I had several ideas on how to tackle this issue with nothing working. Some of these ideas I didn't even attempt because I knew they wouldn't work. It's safe to say I was ready to give up entirely. But some part of me still had hope, so I took a break and promised myself to come back to it later. And I'm glad I did, because I started to think about how rotation works, and that's when everything clicked. There was one simple shape that was about to solve all of my problems. Of course, I'm talking about the sphere. It was that simple. The sphere and its 2D cousin, the circle, were everything I needed. And instead of flashing some complicated math function, I'm going to show you my exact thought process. Let's take a look at a bone. Now, unless you're Pedro Pascal, chances are your bones don't expand or contract. Meaning, if I rotate this bone in 2D space, it should rotate in a circle. And if I rotate it in 3D space, it rotates in a sphere. For instance, if I take my arm and rotate it like so, and process this through the machine learning model, I'll get these points representing my joints. And if you notice something, this also follows a circular path. What does this mean? It means that this joint has to be on the circumference of the circle. It can never be inside of the circle. Except it can. If I were to rotate my arm into the 3rd dimension, in the 2D projection it now looks like this. And if we know that a bone rotating in 3D space rotates along the surface of the sphere, then all I would need to do is calculate where the bone rotates depending on where the joint is, whether it's along the circumference or inside of it. Lucky for me, there's a handy math equation just for this. So after a little bit more coding, I can now predict exactly how the bone rotates in 3D space using only 2D coordinates. And it works flawlessly with multiple bones as well. With all the excitement of finally solving this issue, I polished the code and made sure everything connects up. The head and neck required some additional tweaking, but nothing I couldn't handle at this point. And to make everything buttery smooth, I applied Blender's smoothing to the animation so it goes from looking choppy to looking elegant. After everything I went through, this is it. What you've been seeing throughout this video is the final result of all of my suffering. Not bad for a regular webcam and 3 brain cells. I sincerely hope you enjoyed this video. Although my plan isn't to become a VTuber, you will see this motion capture system in future videos. This is kinda what I made it for. And maybe I'll improve the design at some point. Probably not for a while. Hopefully whatever I build next doesn't take me months to put together. Make sure you hit the buttons below for more questionable inventions, and I will see you later.